The map of our world is about to change. And I'm not talking about China breaching boundaries. I'm talking about the continent of Africa splitting into two.
In the heart of Africa, a dramatic transformation is taking place, altering the face of our planet. Less than 20 years ago, the Earth began to fracture, tearing through territories and even dividing a man's home in two. Africa is slowly tearing apart, hinting at the birth of new lands and seas. But what mysterious forces are causing this massive shift? How will this reshape the future of not just Africa, but the entire world? As all this occurs, can humanity do anything at all? Dive deep with us into this captivating phenomenon, uncovering secrets most remain unaware of. 3 burning questions will be addressed. What's truly driving Africa's split? How will this tectonic dance reshape global geopolitics? And could other continents be next? Let's find out. In 2005, captivating images surfaced, unveiling a breathtaking spectacle in East Africa, a continental rift. Picture this, a massive stretch of land, seemingly unyielding and permanent, slowly tearing apart. But how? And why? Our planet has a secret. It's alive in a way that's both mystifying and majestic. Continents aren't just lifeless, static land masses. They're dynamic and constantly moving. Once upon a time, hundreds of millions of years ago, Earth was a quiet, unified land, a supercontinent called Pangaea. Imagine, all the lands we know today were snuggled up together, surrounded by a vast ocean named Panthalassa. But then, something incredible happened. The Earth's crust, affected by the intense heat from below, began to tear apart, rearranging itself into the beautiful patchwork of continents and oceans we recognize today. And this dance isn't over. Our continents, seated on around 15 to 20 massive tectonic plates, are continuously moving. It's a slow, mesmerizing waltz directed by the intense heat of Earth's core. This is called plate motion, or tectonic shift. Today, as we witness the rift in East Africa, we're essentially getting front-row seats to the next chapter of Earth's grand continental performance. According to NASA's Earth Observatory, the Somalian plate in East Africa is slowly drifting away from its big brother, the Nubian plate. Some people like to call them the Somali plate and the African plate, respectively. Intriguingly, both these plates aren't just distancing themselves from each other, but they're also moving away from the Arabian plate up north. Imagine 3 close friends gradually drifting apart. These friends meet at a place called the Afar region in Ethiopia, where they form a fascinating Y-shaped rift. The Geological Society of London labels this rift between the Somalian and Nubian plates as the East African Rift. Picture this, a stunning stretch of valleys, almost 2,175 miles long, extending from the Red Sea all the way down to Mozambique. The process of Africa splitting into 2 continents is largely driven by the rifting of the East African Rift System, EARS. This tectonic boundary stretches from the Afar Triple Junction in the northeast down to Mozambique in the south. As tectonic forces pull the African plate apart, magma rises to create a new crust, pushing the continents further apart. With the continuation of this process over millions of years, the split will eventually become significant enough to allow ocean waters to flood in, leading to the formation of a new ocean and splitting the African continent. Potential polar shifts, or geomagnetic reversals, occur when the Earth's magnetic poles switch places. While these events have occurred multiple times in Earth's history, their direct contribution to tectonic processes is not yet clear. However, it's hypothesized that polar shifts could have indirect effects on the planet's lithosphere. As Earth's magnetic field weakens during a polar shift, it could influence mantle convection, possibly affecting tectonic plate movements. If such an event caused an increase in tectonic activity in the EARS, it might accelerate the rifting process. However, more research is needed to understand the relationship between geomagnetic reversals and plate tectonics. Supervolcanoes, on the other hand, can have more direct and observable effects on continental structures. The formation of a supervolcano requires a significant upwelling of magma from the mantle, creating a large magma chamber near the Earth's surface. The immense pressure from this magma can cause the crust to bulge and fracture, potentially influencing nearby tectonic boundaries. If a supervolcano were to form near the East African Rift, the immense volume of magma and subsequent eruption could expedite the rifting process by introducing more molten material and altering regional tectonic stresses. This, in turn, could quicken the separation of the continents.